Okay, in class we did a Monte Carlo simulation of this supply chain. In particular, it was a time-based simulation in which we simulated buckets of time or weeks. We're going to recap what we learned about the supply chain in that simulation. This is the fundamental effect that you were able to recreate in your simulation, and you were able to test some changes and what impact they had on this effect. This is the bullwhip effect, which we talked about earlier. So this graph shows one thing that you saw in the simulation. There was variation in the demand, but there was much larger variation in the orders as we moved up the supply chain. And this shows the bullwhip effect on inventories. And again, as you move up the supply chain, the swings in inventory get larger and larger. And this is a slide that shows inventory of Saturn automobiles, and it looks very much like some of the inventory that we generated in our simulation. And just so you don't conclude that the bullwhip effect is something that exists only in automotive supply chains or whatever, here is an example from the computer industry. And this happened in 2001 when the demand for computers dropped as a result of a decline in the .com industry. Two things you want to notice there. One, the chip suppliers who are at the earliest stages of the supply chain were the ones that got hit with the most inventory. They had months of inventory. And if you look at Dell, which is down at the bottom, Dell has a very sophisticated supply chain strategy, and they maintain their inventory at 5 days supply, which is what they always hold. I've worked with a number of companies, and when we chart their weekly or monthly or daily inventories of product, we see patterns pretty much like what you saw in your simulation. You see these wild swings in the inventory, and that has a huge financial impact that we're going to talk about later. But when you see that situation, quite often the reaction is, if only we had a better forecast, if we could do a better job of understanding what the consumer is buying through point of sale information, better forecasting, and so forth. There's two things you have to remember there. One, from your simulation, you saw that improving the forecast did not eliminate the bullwhip effect. You still had a fairly large, or actually a very large bullwhip effect even when you put in the improved forecasting model. Second, there's a lot of variation that is random, and you're just not going to be able to forecast it. You're going to have to develop a strategy for dealing with it. But third, the idea of having a accurate long-term forecast is somewhat wishful thinking. For example, let's pretend that I'm manufacturing soft drink, and I want to forecast how much soft drink I'm going to sell even next weekend. Well, in order to do that, I would have to be able to forecast what the weather's going to be next weekend. And if I could forecast the weather, I probably wouldn't need to make soft drink in order to make money. I could just sell weather forecasts. And if you look at other products, being able to make an accurate long-term forecast might involve being able to predict what the economy is going to do, what the interest rates are going to be, what the weather patterns are going to be, and a lot of other very uncertain things. So a long-term forecast is not the solution to eliminating the bullwhip effect. We have to forecast. We do the best job we can. We use that as a rough plan, but that is not what is going to eliminate the bullwhip effect. Here's another problem that was illustrated somewhat, although it wasn't quite as obvious in your simulation, and that is you can't divide the supply chain up into little pieces and optimize the pieces and get a better result, or the best result. For example, if you were the Tier 4 supplier, no matter what you did as a result of what is going on downstream from you, you're going to get very wild swing in your orders, and it's going to be very difficult to deal with that. On the other hand, if you're the retailer, and maybe you do a very good job of optimizing your operations, but if your upstream suppliers can't respond to your orders quickly, then that's still going to result in large swings in orders and inventories and so forth. So you have to manage the entire supply chain as one piece, and that's what we're going to get into in the next time when we do what is called the integrated supply chain. In other words, the decisions made at each stage of the supply chain are connected, and they're based on information that exists all the way up and down the supply chain. And that's the key to resolving the bullwhip effect, and we'll see that more specifically next time. So in class next time, we're going to make some changes to our simulation to implement some things that are going to allow us to eliminate the bullwhip effect. In fact, the variation in production at the factory will ultimately end up being smaller than the variation that we see at the consumer level. And this lists some of the things that we're going to put in place in order to make that happen. So look forward to seeing you in class.